My name's John Delaney, and I'm at sea on the Thomas G. Thompson off the coast of Washington and Oregon. I'm here as a result of a major program that's funded by the National Science Foundation, and we are looking at all the aspects that are necessary in order to implement a novel, new kind of infrastructure in the ocean to conduct research. The system that we're talking about is called the Ocean Observatories Initiative. The main research tool that we have and our home at sea for a month is the Thomas G. Thompson. It's a global class vessel for oceanographic research. It is owned by the U.S. Navy, it's funded by the National Science Foundation, and it's operated by the University of Washington. The main tool that we use to work in the deep ocean is Jason, a remotely operated robotic vehicle that descends from the surface, from the ship, and is on a cable, a fiber optic cable that conveys both electrical power and has high bandwidth. It allows the scientists on board the ship to have almost total control over the motion, the movement, the sampling, and the navigation of this robot on the seafloor. The robot is a highly flexible system. It has an intermediate package that is above Jason called Medea, which is constantly surveilling the safety of Jason from above, about 50 meters above. The Enlighten'10 cruise has these components: the ship I just mentioned, the submersible that you see on the lower left, and the three areas of investigation are shown on the right-hand side of the map. Altogether, we're preparing for the construction of a series of undersea cabled laboratories that will allow scientists on land to communicate with robots and sensors on the seafloor and to modify their behavior, I might add. About 2.5 weeks ago, we started working near Grays Harbor offshore, did some mapping there as a prelude to this program. Then we moved to Hydrate Ridge, which is directly west of Newport, about 60 miles out, and we spent almost a week and a half working on a methane hydrate deposit there. At this point, we're at axial seamount, which is about 400 kilometers directly west of Astoria and Newport, and we're working diligently to try to map an active underwater volcano known as axial seamount. The goal of our mapping on the seafloor is to understand as thoroughly as possible the opportunities to make new scientific discoveries and new ways of studying systems by being there without being there. But the other is to make sure that the assets that we put in place, the fiber, the expensive instruments, the robots, are safely positioned so that most of the time they're out of harm's way. Let me show you very quickly what it's liable to look like when we have this thing in place. This circle is an example of where we are, and on the left-hand side, axial seamount itself in relief, and at the top, the box-shaped feature with shadows is actually a depression in the top of the volcano known as a caldera, and it's a place where the seafloor drops as much as 200 meters when the magma chamber, the molten rock beneath the surface in the middle of the volcano, moves up and down. So this is a very active submarine volcano. And what I'm going to show you now is an animation of what it is we are funded to put in place inside this volcano. This is a mooring with a platform near the top. It's only 200 meters below sea surface, and there's an elevator moving up and down under control from land, making measurements with about 8 different instruments simultaneously, and we can control where that elevator moves. As we move down the wire of this mooring to the seafloor at about 1,500 meters, or about a mile deep, we see a robotic colony with sensor packages that are all fiber optically connected to the internet. We see autonomous vehicles that are constantly patrolling the environment, and we're coming into an area that is a deep sea hydrothermal system. With this new system we're talking about now, anyone, anywhere with access to the internet will be able to tune into the cameras, to the instruments, to the robots, and find out what's happening at any time of the day or night. We'll be working here for another 10 days, and if we are fortunate in terms of weather, we will be streaming video from the deep sea floor as we go through our work. Periodically we will have commentary that'll go along with the imaging, so please join us, bring your friends. We also welcome your questions. Look forward to seeing you again. Please join us. Take care.